In this video, we are going to see exercise problems in page number 25 in unit 2 motion. Question number 1. A ball is gently dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 ms minus 2, with what velocity will it strike the ground? After what time will it strike the ground? When you drop the ball at a height of 20 meter, its velocity increases as 10 ms minus 2. We have to find out at what velocity and time will the ball strike the ground. Given data, initial velocity u is equal to 0. That is, ball is at rest. Height h is equal to 20 meter. Acceleration due to gravity 10 ms minus 2. We have to find final velocity of the ball, time taken to reach the ground. Formula for freely falling body, v squared is equal to 2gh, and then distance s is equal to half gt squared. Now first we have to find out velocity. V squared is equal to 2gh. Now v is equal to square root of 2gh. Now 2 into 10 meter per second squared into 20 meter is equal to 2 into 10, 20 into 20. Now we have to multiply meter and meter, we get meter squared by second squared. Now when we remove the square, we get 20 meter per second. That is, velocity is equal to 20 meter per second. Now we have to find out the distance. S is equal to half gt squared, h is equal to half gt squared. The height is 20 meter is equal to 1 by 2. Acceleration 10 ms minus 2 into t squared. 20 meter is equal to, when we multiply 1 by 2 into 10, we have to cancel with 2. We get 5 ms minus 2 into t squared. Now we have to find out t. So we have to bring it to one side. 5 ms minus 2 into t squared is equal to 20 meter. Now t squared is equal to 20 meter into the 5 becomes 1 by 5 and s squared by meter. Now meter and meter get cancelled. So we get 20 by 5 second squared. Now t squared is equal to 4 second squared. T is equal to 2 second. Or that is, to find out the time, we have to use this formula also. That is, v is equal to gt. Now from this, t is equal to v by g is equal to 20 meter per second by 10 meter per second squared. Now when we divide 20 and 10, we get 2 meter per second into second squared m. Now m and m get cancelled, squared and s get cancelled. So we get time is equal to 2 seconds. So in the result, final velocity of the ball to strike the ground is equal to 20 meter per second. Time taken to reach the ground is equal to 2 seconds. Question number 2. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 meter and 20 seconds? The diameter of a circular track is given as 200 meter. An athlete completes this track within 40 seconds. You have to find out the distance covered and the displacement at the end of 2 meter and 20 seconds. Given data, diameter of a circular track d is 200 meter. Time taken to complete one round t is equal to 40 seconds. We have to find distance and displacement covered at the end of 2 meter and 20 seconds. Formula: distance is equal to velocity into time. Displacement is equal to final position minus initial position. Solution: time taken for complete one round t is equal to 40 seconds. Radius of the track r is equal to diameter of the track by 2. So 200 meter by 2 is equal to 100 meter. Velocity is equal to displacement by time. The displacement is 2 by r by t is equal to 2 into 3.14 into 100 by 40 meter per second. When we multiply 3.14 and 100, we get 314. So 2 into 314 by 40 meters second. Now when we cancel 2 and 40, we get 20. So 314 by 40 meter per second is equal to 157 by 10 meter by second. V is equal to 15.7 meter per second. Now we have to convert this minute into seconds. 2 minute 20 second is equal to 2 into 60 plus 20 seconds. 120 plus 20 second gives 140 second. Now distance covered at the end of 140 second is equal to velocity into time. Velocity already we found out, that is 15.7 meter per second into 140 second. When we multiply this, we get 2198 meter. Here second and second get cancelled. Now circumference of the track is equal to 2 by r is equal to 2 into 3.14 into 100 meter. So 2 into 314 meter is equal to 628 meter. Now we have to find out the number of rounds. The number of rounds made by the athlete is equal to distance covered by circumference of the track is equal to 2198 meter by 628 meter. Now meter and meter get cancelled. So we have to get 3.5 rounds. Now let us assume that athlete starts the round at point A. At the end of the third round, the position of the athlete is A. At the end of 3.5 round, her position is B. Now what is displacement? It is the shortest distance between final position and initial position. So displacement is equal to final position minus initial position is equal to 200 meter minus 0 meter is equal to 200 meter. Now the result, distance is equal to 2198 meter and displacement 200 meter. A racing car has a uniform acceleration of 4 ms minus 2. What distance it covers in 10 seconds after the start? That is, acceleration of the car is given as 4 ms minus 2, and then we have to find out the distance for after 10 seconds. Acceleration A is equal to 4 ms minus 2. Time t 10 seconds. Initial velocity u is equal to 0. To find distance covered by the car after starting 10 seconds. So formula to find out the distance, you know that S is equal to ut plus of at squared. Solution, S is equal to ut plus of at squared. Initial velocity is 0 into time 10 seconds plus 1 by 2 into acceleration 4 ms minus 2 into time 10 second whole squared. Now 0 into 10 we get 0 plus 1 by 2 into 4 ms minus 2 into 100 seconds squared. Now when we cancel 2 and 4 we get 2 ms minus 2 into 100 seconds squared. Now second squared and s minus 2 get cancelled. Now 2 into 100 we get 200 meter. Now result, distance covered by the car after starting 10 seconds is equal to 200 meter. Thank you students.